Hello everyone. Today we are here to learn about ID3 algorithm of machine learning. In generic terms, the ID3 algorithm is just a way in which machine analyze and learn. So initially we will be provided a data set containing sample input and outputs. So our machine is going to learn from this data set, and in future if it will be provided with any other input, then it might build output itself. So the machine will basically build a tree which will only contain the choke keywords. So coming to the terminology, so the things we are going to use in this is basically entropy. So entropy is basically the randomness in the given data set. So we will have different classes inside the sample data. For example, there are three different sort of inputs in our provided data set. So a class is three different classes of output. So there will be entropy of a whole class, and there are different attributes, so there will be entropy of different attributes, and information gain it will be evaluated using this. And so basically while building a tree, there are certain parameters which we have to take care of while taking a attribute as a root node. That is, if its gain is max or if its gain is most greater than all other attributes left, then only it will be the root node. So basically we will evaluate gain of each attributes, and the maximum of them will be placed as root node, and we will proceed further. So we are going to evaluate manually. So first we are evaluating the class entropy. So first, as I said, there are three different kinds of outputs. So that's N1, N2, N3 as what we are considering here. So here we are evaluating the class entropy, and you can do the calculation, but as I have shown here, it will be this. And for for each attribute evaluating gain, so for root node we have to just evaluate the gain, or for gain we have to evaluate the attribute entropy and its information gain. So first we are making classes inside the attributes. So for risk attribute, there are three different classes of input, that it's high, moderate or low. So for each we are evaluating information gain, and then we are evaluating entropy. So from that entropy we are evaluating gain, that's class entropy minus attribute entropy. That same procedure we have to follow for credit and for death. For example, for again taking the example that credit contains three different classes, the classes or types of credits, that bad, unknown and good. So we are evaluating again the information gain of credit, and then entropy of attribute credit, and then we are going to the gain of credit, that's gain of whole class minus gain of attribute credit. So from this we are getting this, and similarly for death, and similarly for collateral. So after that we got all the attributes, all attributes are comprising of their own gain. Then we compare all the gains, then we found that the risk gain is maximum, so that will be the first root node. So risk will be the first root node, and there are three different ways in which the risk can occur, that's low, mid and high. And for each low, mid and high we are going to proceed further the same operation. So for example, all the cases initially the risk is now not our maximum priority, and if we are going to the sub branch of risk low, then we will just see these cases in which risk is low and not on the risk. So again we have just cases, and then again we will evaluate information gain of these three things, and again which whoever have maximum information gain will be our next root node under the risk low branch. Similarly for risk mid branch, similarly for risk high branch. So that might go for 1 or 2 steps more. Basically maximum it can go is just 4 steps, because 4 is the total number of attributes. None of them will repeat on a single branch, so the maximum length will be 4. And after we evaluate the whole thing, similarly it will go on easy as we proceed further. So after at last we will found that it is very reduced one. So basically if we ask risk, when risk is low and all collateral is high, low, and what else, all the attributes. When risk is low, credit history is unknown, death is that anything, collateral is anything. So from this tree we can just see that how it's very easy for computer to know that if risk is low, then our output will be this only. So computer learned that. Basically it's very different from storing the information. We basically are not storing these inputs, and we are not checking that the in future the given input is just among this one and we give this output. Not that. Basically the computer build a tree, and it reduce the whole thing, that if risk is low, then output will be this, just this one. So by this it is the decision tree. If risk is low, then the decision make is it's great, that income will be greater than 35. So finally we made our whole, after proceeding this whole, we will get the final decision tree that all of the cases. So for now that will be it. That this is the ID3 algorithm of decision making. So there are many other algorithms except this one, and more capable or more efficient algorithms are also there, but it is the simplest and most sounding algorithm in the course. So this will be it for now. Thank you.